Most students don't fail calculus exams because they lack intelligence. They fail because of how they structure their study time. The biggest trap in any college math course is relying heavily on video lectures, tutorials, and solution walkthroughs. Spending hours watching an instructor solve problems creates a powerful but dangerous illusion of productivity. You follow the steps, the logic makes sense, and you build a false sense of confidence. To break this illusion, you must replace observation with a highly specific routine we call the exam simulation protocol. This protocol requires a strict physical setup, a full unsolved problem set, blank paper, pencils, and a dedicated timer. Shifting your workflow away from screens and toward active, independent execution is the only measurable way to prove you actually comprehend the material before you walk into the exam room. Step 1 is securing your environment. Shut down your browser, exit your digital tutorial aids, and close the lid of your laptop. There is a massive cognitive gap between watching an expert navigate a mathematical proof and having to generate that exact sequence of logic entirely on your own. Before you begin, you need to curate a comprehensive, full-length problem set. Many students fall into a false confidence trap. They complete 1 or 2 simple examples from the textbook, get the right answer, and immediately declare mastery. This chart compares the difficulty ceiling of stopping at 2 problems versus completing a full 10 to 15 problem set. Notice how the difficulty scales aggressively upwards as the volume of the set expands. If you stop early, you never encounter the complex multi-step integrations that professors reserve for the end of the chapter. Pushing through that elevated difficulty curve bridges the gap between basic familiarity and actual independent application. A practice session only holds value if it accurately mirrors the exhausting volume and scale you will face on test day. Step 2 is the pressure test. Set your timer to 60 minutes and start the clock. From this second forward, there is a strict ban on pausing the timer or consulting your notes when you inevitably get stuck. This process is designed to feel difficult. The work will be slower, harder, and much more unfamiliar than watching an instructor effortlessly write on a whiteboard. This diagram illustrates the struggle phase. Notice the active loop of attempt, failure, and alternative approach, directly compared to the dead-end shortcut of simply looking up the answer. When you force your brain through that alternative approach node, you have to independently synthesize foundational calculus rules to find a new path forward. Hitting a mental wall without a lifeline isn't a sign of impending failure. That panic is the precise mechanism required to build long-term neural pathways. Step 3 is the postmortem. When the timer hits 0, put down your pencil, pick up a red pen, and switch your mindset to greater. Go back through your entire problem set and aggressively audit your work. Identify and highlight every single error you made under pressure. You need to categorize these mistakes into 2 groups: simple mechanical slips, like a dropped negative sign, and total conceptual failures, where your underlying logic broke down. For every conceptual failure, write out the exact corrected logical step in red ink immediately adjacent to the error. Top-performing math students do not possess a naturally perfect error-free brain. They simply maintain a higher volume of deeply analyzed mistakes than everyone else. Solving raw problems without subjecting them to an honest, aggressive mistake review phase yields absolutely 0 improvement in your retention. Look down at your practice set. That paper, heavily marked up with red ink, crossed out equations, and corrected steps, is tangible proof of your exposed knowledge gaps. This physical, undeniable proof of cognitive exertion holds infinitely more value than an invisible, untrackable history of watched tutorial videos. If your brain feels entirely exhausted right now, that is a sign the simulation worked. You executed the protocol flawlessly. By front-loading all of this friction and struggle into your practice session, the actual exam environment will feel completely familiar and highly manageable. Your final directive is simple. Strictly replicate this exact timed active workflow for every remaining chapter in your calculus syllabus. Watching is observing. Aggressive, repeated practice is everything.